Hi, my name is Gina Porter, and I'm going to talk to you for the next few minutes about the second 9 weeks in second grade math, specifically telling time and working with fractions. So if we look at the overview of the second 9 weeks in second grade math, we can see that they start the 9 weeks by continuing their work on addition and subtraction with non-standard algorithms. They started that during the first 9 weeks, and they're going to continue working on that. Then they move into organizing and interpreting data, working with graphs. Then they start to work on telling time and recognizing and representing fractions. So we're going to talk right now about time and fractions. In first grade, students were telling time to the hour and the half hour. Right now, second graders reviewed telling time to the nearest hour and half hour earlier in the year. Now they're working on telling time in 5-minute intervals. So for instance, now they would be able to tell on the first clock that it's 7:25, and on the second clock that it's 2:40, and here that it's 1:55. And this is one of the most difficult for kids because the hour hand is so close to 2. A lot of kids will say it's 2:55, and so you have to have a conversation about the fact that 2:55 is almost 3 o'clock, and does it look like it's almost 3 o'clock? No. So when the hour hand is close to this, it becomes a little more difficult for students. So now the minute hand is always on one of the numbers. It's on these 5-minute increments. And then later in the year, we'll start telling time to the nearest minute, where the minute hand is not necessarily on one of the numbers. Additionally, second graders need to distinguish between AM and PM. For instance, is it more likely that Evan walked to school at 7:30 a.m. or 7:30 p.m.? Larry ate dinner at 6 o'clock. Is it more likely that he ate dinner at 6 a.m. or 6 p.m.? So they're telling time in 5-minute increments, and they're distinguishing between activities that happen in the AM and things that happen in the PM. And like I said, later in the year, they will start telling time to the nearest minute. In second grade, in the second 9 weeks, they also work with fractions. When they work with fractions, they partition objects into equal parts. For instance, if I have a rectangle, I can draw lines in it, 3 lines, and separate it into 4 equal parts. Or I could take a circle and draw 1 line down the middle and divide it into 2 equal parts. When we're working with fractions in second grade, they're naming the parts using words. They are not writing the fraction symbol. For instance, they would not write, for 1/2, they would not write 1/2. They are just going to use the words and talk about them, or they might read it written out in words, but not, like I said, the normal fraction notation. They're going to be partitioning regions or shapes into halves, fourths, and eighths. And one of the things that they spend a lot of time on, one of the most important things that they need to take away from that, is how many pieces does it take to make the whole? If I look at one whole, is it divided into 2 equal pieces, or is it divided into 8 equal pieces? We spend a lot of time talking about what makes one whole. And they need experience partitioning the objects themselves, not just shading in parts or shading in a given fraction. So it's very important that they actually have some experience in taking a rectangle, for instance, and if they're trying to shade it, divide it into fourths or partition it into fourths, they have to figure out first, how many lines do I need to draw in here? And then they're going to find out, because a lot of them say, oh, I need it into fourths, so I'm going to draw 4 lines in here. Well, they end up obviously with 5 regions instead of 4. And So, they have to figure out how many lines do I have to draw to end up with the number of regions, the number of parts that I want. And they also have to learn some estimation skills, where should these lines go? And if I wanted to divide it into fourths, it's probably a good idea to divide it in half first, and then to divide each half into half. And so there's a lot of skills that are gained just by the very act of having to partition a shape themselves instead of having it already shaped and partitioned for them. And all they have to do is shade in a fraction. They have to look at a fraction, look at a region that's been partitioned into equal parts, and be able to name that fraction. Again, with words. We're not writing in fraction notation, but they should be able to talk about the fact that in this circle, 5/8 has been shaded, and that 3/8 have not been shaded, and that each little segment is 1/8. So here, this is 1/8, and one more 8, and one more 8, and one more 8, and one more 8. So all together, there are 5/8 shaded. Over here, this circle has been partitioned into 4 equal parts. 1/4 of this circle has been shaded a light green, and 3/4 of this circle has been shaded a dark green. And each of these different parts is 1/4 of the whole. It takes 4 of these parts to make the whole circle. So as we work with fractions, we start looking at fractions and having them explain what happened to the size of the pieces when I divide it into more parts. So here we have the circle and we divided it into 2 equal pieces. Here we took the same size circle, but we divided it into 4 equal pieces. And so it takes a while for some of them to understand that if I divide it into 4 pieces, there's more pieces and the pieces each get smaller. When I divide it into only 2 pieces for the same size circle, the pieces are much bigger. And that's difficult for some of them because they're so used to whole numbers. They want to say that 4 is bigger than 2, that 1/4 is bigger than 1/2. And so they need lots of experience at looking at models, looking at pictures of fractions, so that they can get that idea in their head that if I have more pieces, and here 1/4 means that it takes 4 pieces to make the whole, so the pieces had to get smaller than when I divided the whole into only 2 pieces. In 2nd grade, they use concrete models and they start naming fractions that go beyond one whole. And they, again, they're having to explain how many parts make a whole. Here, I want to caution you about using the phrase, how many pieces altogether. A lot of times when we're talking about fractions and we're talking about the denominator, we tell students to count how many there are altogether, and that is the denominator. Well, when we start to look at multiple wholes, when a fraction goes beyond 1, and we tell them that the denominator is how many pieces there are all together, they may be inclined to count 1, 2, 3, 4, 5, 6, 7, 8, and say this is eighths. But we have to remind them that that bottom number, or that denominator, names how many pieces make one whole. So here's a whole, and there are 1, 2, 3, 4 pieces. Here's a second whole, and there's 1, 2, 3, 4. So it's not the pieces all together, it's how many pieces make one whole. So students should be able to say that it's divided into fourths because there are 4 pieces that make up one whole. And then if we want to talk about the shaded part, that 1, 2, 3, 4, 5, 6, 7 pieces are shaded, but it's 7/4 because there are 4 pieces that make up one whole. Or the students could say this is 1 because one whole shape is shaded in. 1, and then 1, 2, 3 of 4 pieces are shaded. So it's 1 and 3/4. They need to be able to name it both ways, 7/4 and 1 and 3/4. And again, they're not writing this with fraction notation. They're just talking about it and using words to talk about it. And it's very important, again, that they really understand how many pieces it takes to make one whole. As they're working through this, they need to see some examples and some non-examples. This is divided into 2 pieces, 2 parts, but this is not 1/2 and this is not 1/2 because they're not 2 equal pieces. And then they have to look at these others and talk about why or why not is this divided into half. Well, thank you for watching. Again, my name is Gina Porter, and I'm the math specialist here. If you have any questions or comments about this topic or any other topic in our math curriculum, feel free to contact me via email, jporter@csisd.org, or you can call me up here at Rock Prairie and ask for me, and they will get a message to me. There will be another Math for Parents training for the third 9 weeks on Thursday, January 5th, 2017. And I hope to see you there. Thanks again for watching.